We've been asked to prove that this is in fact a trig identity, and so over here we have all of our approaches, things that we could try. There's no addition here, so I can rule out common denominator, but conjugate pair seems like that might be appropriate. So if I look at the conjugate pair, I'm usually looking in the denominator, and so here I see the conjugate pair here would be 1 minus secant theta. I'd multiply that top and bottom. So on the top, I'm not really going to multiply it through. I'm just going to leave it in factored form in case it can cancel out later. But here we can multiply through because we know it's going to clean up the denominator. 1 times 1 is 1. The inner terms will cancel out. Negative secant times secant is negative secant squared theta. And this will still equal what we have here. So I'm not sure that this is making things any better, except that this looks like it might be something or close to something on my trig identity sheet. So I'll check that out. So I pasted the formula sheet in here, and I see I've got a tangent squared. It should be squared. We'll fix that. And I've got 1 minus secant squared, and this one has all of those same terms. So now I'm looking to see if this could maybe be rearranged, or here it is, tangent squared x equals secant squared minus 1. Well, I have the opposite of that. So instead, if I had done 1 minus secant squared x, that would be equal to negative tangent squared x. So now I could see I can replace this. We're going to replace that with what it's equal to, negative tangent squared theta. And so now those cancel out, leaving just a negative sign. So I have 1 minus secant theta all over negative 1 equals, again, what we have on the right. Well, if I distribute that negative 1 and say, hey, I'm going to take that to here, that makes that negative 1, and it turns this negative into a positive, and that is no longer there. Well, this is the same as negative 1 plus 1 over cosine of theta, because that's what secant is. And if I were to find a common denominator, I could replace this negative 1 with negative cosine theta over cosine theta. Again, plus 1 over cosine theta. And now we have an exact match, because our 1 is positive and our negative cosine theta matches exactly, and we're over cosine theta. So we've now proven this identity to be true.